Good morning.
Waalaikumsalam,
Um,
doktor.
okay, we wait for 1 or 2 minutes for your friends. Assalamualaikum. Good morning.
Morning, doctor.
Okay, we wait for a while for your friends. Morning. How many hours? 33. 37. Okay, we wait 1 more minute, okay? Okay, let us start our session this morning with a moment of silence, a remembrance of our God. Al-Fatiha. Okay, we will have our first test this Friday, 26th of November. Good luck to you all. I think you have done quite sufficient exercise to that. What is stress analysis? What is strain analysis? And how to relate it, stress and strain. And to do the Mohr circle. We convert from strain to stress, stress to strain at principal direction. We draw the Mohr circle from the principal direction. And then we find back where is the X, where is the A, where is the X dot, whatever it is. But we trace back. And stress analysis, we have to do it from the beginning. How to get the sigma X or sigma Y or tau XY through the TR over J or MY over I, VQ over IT, and P over E. Are you with me, guys?
Yes, doctor.
I think you have done a lot of exercise on that. I'm confident you can do that. Okay. Anyway, today I would like to continue because we have 7 chapters. Okay. We have 7 chapters. We are only covering 2 chapters for now, and then just starting the failure theory. Why I cover the stress analysis and strain analysis so long? Because this is the most important things in applied mechanics. As an engineer, you don't know how to do the Mohr circle, the stress analysis, the principal stress, 3D Mohr circle. What is in plane, maximum in plane? What is maximum absolute? You don't know about this. you'll be in trouble as an engineer. Are you with me, guys?
Yes.
So I think you have done a lot of exercise on that. I'm sure you will do okay in the test. Okay, today I would like to continue on the failure theory. Actually, our subject here is the most important things as an engineer. This failure theory is related with the stress analysis because you have to find sigma 1, sigma 2, and sigma 3. So last week we learned about how to do the 3D Mohs circle. Okay, if you who are still not confident with that, contact me. Okay, you can ask during the class, whatever it is, because that's the most important things. When you work as an engineer, you must know what is the maximum stress and everything. So we have 5 failure theory. What is the first one?
Rankine.
Rankine. We compare sigma 1 into the sigma y, and the difference is satisfactor. Some satisfactor they put it as F, some they put it N. Same thing. The symbol for satisfactor, okay? Satisfactor higher than 1, what's the meaning?
Safe.
Safe. Safety factor equal to 1, what's the meaning?
Ngam.
Exactly at the limit. Okay? So safety factor below than 1?
Failure.
Failure. So this one, we compare only one value to that one. The second theory is maximum shear, maximum strain theory. What's that? Sigma 1 minus mu, sigma 2 minus mu, sigma 3 is equal to sigma y over n. And the third one is Tresca stress, maximum shear stress theory. Sigma 1 minus sigma 3 equal to sigma y over n. So this value compared to that one. That value compared to that one. That value compared to that one. So for that theory, one value compare only. That theory, several value to compare. So what do you call sigma 1 minus sigma 3 here? The formula is Tresca. Sigma 1 minus sigma 3 is the meaning of Tresca stress. This is Tresca stress compared to sigma y. So the Tresca stress must be lower than sigma y in order for it to be safe. And then number 4 is the energy theory. Sigma 1 square plus sigma 2 square plus sigma 3 square. Okay? Minus 2 mu, sigma 1, sigma 2 plus sigma 2, sigma 3 plus sigma 3, sigma 1. The whole thing, that one square root it and compare to sigma y over n. So what is called this one? Saint-Venant stress. The whole thing here, Saint-Venant stress. And the fifth one is same thing like here, we don't have this one. So sigma 1 square plus sigma 2 square plus sigma 3 square minus sigma 1, sigma 2 plus sigma 2, sigma 3 plus sigma 3, sigma 1. And the whole thing is square root it. This is what you call von Mises stress. Sigma y over n. Von Mises stress. So the theory that's suitable for brittle material is the first two material here. For brittle. Yeah? This the last three here is for ductile material. So almost all metal are ductile. Still are ductile. What's the meaning of ductile? That one. This is brittle, brick. Ductile here, we have a lot of plastic area here. So ductile material, most metal, steel, aluminum, copper are all ductile material. So the last three theory. So the most famous one is the easiest one is the Tresca. And the last one here is von Mises. So these two theory here is the most. If you do finite element, you must learn to use a finite element now. Learn how to use the software finite element. Do a simple, there's a package on the computer. Do a simple testing there. You can do that one. You put the properties of that metal there, you put a load there, you can find the deflection. You can find a lot of things. You can do that on finite element. Are you with me, guys? You must learn that because you have you learned about the theory of finite element? Hello, have you learned about the theory of finite element?
No.
Not yet. So there's a class on finite element, maybe next semester. How about the others? Have you guys go to
No.
theory finite element analysis?
No. Haven't.
Maybe next semester. So you can try to learn how to use the finite element package on the computer. You can download it and sys, Beckers, a lot of things there. So when you put load there, you can find the deflection. Or you can find the theory. We have theory of deflection already. Remember in the solid one, what is the theory of deflection? So remember not, the last chapter. Come on. What is the topic of last chapter in solid one for deflection?
Strain transformation.
Solid one.
Solid one.
You learn about deflection in solid one. What's that? Come on, guys. What happened to you? What is the theory of deflection in solid one? Crack your head now. Ask yourself. Remember this not? Remember this not?
I remember this one.
What theory is this? Parah kamu ni. You are a rubbish engineer. What is this? What theory is this? Yes, everything is lobe there. What is that? Theory, so what? What is the title of the topics? Macaulay. The theory is Macaulay theory. Nampak tak? You guys learn for the test. After test, gone. It's none in your head. Take a lot of time to call it back because you never dig that ilmu. You just memorize. When you dig it, it's always with you. You integrate it. What do we have here? dy dx. Let's say the moment here is 5x squared, whatever it is. 2x. Let's say the moment is like that equation. So integrate here. Integrate there. You got what? 5x integrate to the cube over 3 plus 2x squared over 2 plus e. Integrate again. We got ei y. 5x to the power of 4 over 12 plus 2x to the power of 3 over 6 plus ax plus b. So this is the formula of deflection. EI here, put it back here, 1 over EI. Y is deflection. The graph of y and x. Whatever x here, what is the deflection there? and x equal to 0, what is y? X 0, 0, 0, then what is y? You find the A and B through boundary condition. So those are the boundary condition, as those are the deflection theory. Same thing here. Yeah. So you can check the deflection of that by the Macaulay method, or you can use the finite element. So this computer program is so much now. You can find the deflection there. You can find the deflection here. At any point there, you can find the deflection by the theory or by the software method, finite element. So you can do that one. Okay, no problem. Put it aside first. Yeah, put it aside first. So we have a 5 theory there for failure theory. And then sigma y over n. So these are the most famous one. What I call just now, because both of these, you can ask the computer program, what is the stress? What is the von Mises stress? These are the meaning of von Mises stress here. This one square, integrate it, and differentiate it, square root it, and then you can find the stress. The stress must be less than sigma y for it to be safe. Yeah, those are basic functions. This is one value only. This is several value. Whatever it is, this is easy for you to understand. And when the limit is there, that is sigma y. So whatever stress that we calculate here, the stress must be Rankine stress, the Saint Bernard stress, Tresca stress, Higgs stress, and von Mises stress. The stress must be less than sigma y for it to be safe. Clear now?
Clear.
Okay, now up a little bit. Remember that we don't just learn this formula just to punch calculator and use it. You don't understand. You want to learn until you understand what is that. You must create question with another question with another question to understand this. Okay, from here, can you ask something? From what we shown here, can you create something, question something for you to make you more understand? Okay.
Which one is more applicable?
Compared to that one and that one. You can check that later on. Just basic formula here. Try with a simple one here. Sigma 1 equal to sigma y over n. Yeah. Whatever value here, whether one is the one compared to the one. Try to understand the n. When the n is equal to 2, where is my sigma? Or sigma stress here, sigma 1 or whatever, sigma Rankine, whatever. Where is my sigma Rankine there?
Lower than sigma y.
Specific.
Half of the sigma y.
Exactly. That is understanding. That type of question you have to ask. When this is 2, so this is halfway down. So that's the meaning of set factor of 2. Double to failure. Are you with me?
Yes.
Your maximum stress, sigma maximum there is equal to 100. And the yield there is equal to 200. So, how many times it's more to fail? Double. That's the meaning of safety factor. Are you with me?
Yes.
What if safety factor of 3? Here. We set the maximum. Now safety factor of 3. What the meaning?
1/3 of sigma y.
3 times. When we have the maximum stress, 3 times more 3 times more. Let's say this value is 66.6 times 2 times 3. Become 200. That's the meaning of safety factor of 3. Or 1/3 of the limit. And we have maximum stress happening there. This is the happening. This is the limit of the material. The happening there. If the maximum the maximum stress is there, so we have 3 times more. Double, triple. It's the minimum safety factor of 3. Okay. Now another question. If you want to design something, we set the safety factor, or after we finish, we calculate the safety factor.
We set the safety factor.
Exactly. So what is the safety factor that we set? Is that enough? Safety factor 1 there?
Definitely no.
Give example. Question again. Give example why we cannot accept safety factor 1.
Risk.
Say what?
To failure. Risk fall to failure.
Yeah, risk to failure exactly at the side there. For example, what? Give an example for you to understand. If not, give a simple example.
The bin cannot hold anymore.
No, that is not example. Let's say you design a chair, stool. Okay? Are you with me?
Yes.
So you sit here. So you sit. This is for the normal guy in the class weight 70 kilogram. Maybe the girls weight 50 kilogram. So maybe there's one of 2 guys who is quite big. The weight is 100 kilogram. So you design the load for 100 kilogram people. Sit there. Or 1,000 Newton. Sit there. And then you select the size. Divide by 4 here. And then you select the size. The size maybe at that time is, I don't know. Maybe this is plastic. The size is, let's say 25 mm. The diameter is 25 mm or 50 mm. I don't know. 50 mm. Each one of them 50 mm. And the stress is exactly, divided by the area, exactly the stress is 200. Let's say, no, this is plastic. The sigma Y for plastic, let's say 70 megapascal plastic. Or maybe the plastic is less, 30 megapascal. Okay? For that 20 megapascal there, you calculate that one, divide by the size. Exactly the size is 20 megapascal. Your sigma maximum is 20 megapascal. So safety factor is sigma 1 and sigma Y n. So it's 20 there, and the limit is 20 there. Your n is equal to 1. Why do we don't want to have n equal to 1? Let's say that day he wear a little bit jacket. The weight become more than 100. Maybe the weight there 100.1 kilogram. So the chair become fail not?
Fail.
This is what I call example. Make you understand. Unexpected things come. Failure already. We don't want it to design to be at failure. So this is why we choose a safety factor. For normal engineering, size, to make that safety factor, that one higher than 1, so make this one bigger. 50 becomes 60, So the stress become less. And then when the sigma 1 become less, the yield is maintained that one. So this one become 15 because we make the size higher. So the stress become 15. The limit is 30. So safety factor is more than 1, maybe 1.3 or 1.2. So we play around with what? Size. We make the size bigger, the stress become less. The limit is still the same. The actual loading stress become less when we make the size bigger. So this is the principle of engineer. That's why this topic is very important for all engineers, whether you are electrical engineer, whether you are civil engineer, whether you are working with the helicopter, we are working with the aeroplane up there, we are working with the car on the road, you are working with the ship on the sea, in the sea. Whatever you are doing, you are a civil engineer, make the building, you are the electrical engineer, whatever engineer you are doing, chemical engineer, whatever, at the end of the thing, you are going to use a product. You're going to use a solid product. You're going to use a plastic for your container. You're going to use your steel for your beam. You're going to use even your electrical conductor current, that one is also a metal. Are you with me?
Yes.
So if you don't understand what is the failure theory, all the product that you are designing will be in fail. That's why this topic is very important for all engineer. Apatah lagi mechanical engineer. So what does engineers do? Fahamkan balik ni. It's very important ni. This the size of the things that you want to do. The product. Whether it's torsion, it's a bending moment there, bengkok je ni, bending moment, or a tensile, or shear, you can convert into stress. And you can find the stress maximum. The stress you calculate only in XY direction. 20 degrees from XY, you cannot calculate. You have to do the analysis. Yeah? What are the job of an engineer? Make decision. That's why we learn about making decision. About the 7 highest level in your head here is make decision. Your akal to make decision. That's why you have to learn from the level 1. You read, you write, and then you recall it. Number 2. Number 3, you dig it to understand it. And then your number 4, you have to apply it. Number 5, you have to analyze it. And then you can compare, and then you make decision. This is what engineers do. This is what you yourself who have akal do. So engineers always use akal to work in making decision. Contoh paling mudah. Example, this is job of an engineer here. To make a building tiang, katalah tiang rumah lah. Tiang apa-apa pun senang nak faham lah. Loading kat atas ni. Kalau loading macam ni pun boleh, tak ada masalah. Tekan, tarik ke whatever it is. Ada loading tak? Ada. Can I make this size bigger? This one, bigger. Can I make the size bigger?
Can.
Answer me first.
Can.
Can. Why don't you make it bigger? Ni nama akal ni. Try to use your akal now. Don't memorize the theory. Tiang rumah tu besar ni. Kenapa tak buat dia besar ni? Simple akal. What is that?
Halang jalan.
The tiang rumah besar ni, size is that big. Why don't you make that tiang besar ni? Simple akal will answer that. What is that? Why is that?
Cost.
Huh? I couldn't hear you.
Cost.
Cost, exactly. Money. You waste money on the material. Bigger material, you have to buy more material, more money. Waste of money. The second one. Why you tiang rumah besar ni? Why cannot I make the tiang besar ni?
Cannot hold the weight.
Bahasa mudah dia apa?
Failure.
Patah.
Patah.
Failure lah. Kecil, failure. Besar, rugi. What is the best size? Itu datang calculation. Besar ni patah, besar ni rugi. So antara ni dengan yang tadi tu mana yang size yang sesuai? You have to make decision. Ini patah, sini rugi. Sini patah, patah tu rugi juga, sini rugi pun rugi juga. Tak work, and then what is the best size? That is the job of an engineer, kalau you nak faham. Making decision what is the best size if you want to make something. Inilah kerja akal, dikonfirmkan dengan calculation. Bila akal kamu dah berfungsi, you become a manager at company, semuanya dalam this category. Here not good, here not good. What is the best? Good tadi tu. Everything, not just size. You do a meeting. You make a long meeting. Everything coming in, you cannot solve things. You make a very short meeting, only 10 minutes only. Nothing coming out yet. To decide time for meeting is also the wisdom of an engineer. To start your factory, what time to start? To start your shop. You want to open the shop at 8 o'clock or 8:30, 9 o'clock, 9:30, 10 o'clock. You open it too early, nobody come. You open it late, people are waiting for you. What is the best time to start? Even a simple decision making require akal. Are you with me, guys?
Yes.
And this is the point that I want you to use your akal. Decision making. You want to open a restaurant. Okay. You want to buy fish. You want to buy fish. You go to the pasar borong there, you buy very cheap fish. Maybe you can buy maybe a few ringgit per kilo. And then after cook, you can sell it for 1 ringgit or 150 ringgit per piece after you cut the fish. After you think from the beginning, oh, if I buy this cheap fish, so people buy with very small token of money only, maybe a lot of people will come to my shop. One people taste it, it's not nice anymore because this maybe this cheap fish maybe already 3 or 4 days before. So once they eat that one, tomorrow they won't come to your restaurant anymore. You are being penalized. And then you buy expensive shop, expensive fish. You buy for 40 ringgit per kilo fish. And then you cut it to small pieces. You cannot sell 5 ringgit or 4 ringgit or 3 ringgit per pieces. You can sell it only for 12 ringgit or 13 ringgit. If not, it's not coming back. The return is not coming back. Yeah. So you sell it 12 ringgit or 13 ringgit per pieces or 15 ringgit. When people come to your shop, they buy, they taste it, oh very nice. When you pay it, kali makan 18 ringgit, 15 ringgit. Do you think they will come back tomorrow? or the day after or next week?
No.
No, you will be penalized again. So what is the best price that you want to put there? Where is to find the best fish to get this suitable price here? It's all about akal. Are you with me?
Yes.
Bagi orang Islam ini nama dia sunnah wal jamaah. Ini yang orang tak faham. Ramai pun orang sebut sunnah wal jamaah tapi tak kenal. Sunnah wal jamaah ni lah mengikut kebijaksanaan Rasulullah. Akal yang bijaksana tu make a decision. Ini yang ramai tak kenal. So the job of engineer is making decision. What is the best size? That material, what is the best size? So, faham saya cerita konsep ni biar kamu nampak. Baru kita cerita aplikasi dia. Kalau kita aplikasi konsep tak nampak, buat penat kamu jadi engineer nanti. Tak nampak tujuan engineer tu. Are you with me, guys?
Yes.
So now, you know that we don't want to design things that is satisfactor is one. So normal things that we design, what is the satisfactor? Normal engineering product, what is the satisfactor?
2 or 3.
Yes, exactly. So around 2 to 2.5 satisfactor. This is a normal product. Yeah. We designed the chair for one people there. Suddenly there's another people sit on top of you. Still sit. That's the meaning. When unexpected things happen, still safe. Why we don't want to satisfactor of 5 there? Answer me again. We have discussed just now.
Rugi.
Apa yang banyak tu?
Material. Cost.
Yes. We have to use a bigger material. So waste of money. Rugi. That's why we don't want this to use a bigger satisfactor. Kenapa tak sini? Unexpected thing come, fail terus. You buy cheap wire elektrik, socket no, cheap wire elektrik tu kedai RM2 tu. Kan dia panggil kedai RM2. Dulu kedai RM2, sekarang kedai Sebaneka. You buy the cheap wire for plug that one. The size of the wire is very small. You don't know, you cannot see because you are a user only. For normal, okay. When the lightning is there, a bigger current a little bit. The lightning there, a current a little bit higher than the normal one. Bam! Terbakar ada plug tu. You don't know about it. When you don't have a mentality of an engineer, you don't know how to check the size of the wire. You just buy that one. Mak kamu tu, yang perempuan ni yang saya risaukan. Pernah ke dia check size wire ni pernah? They never care. They are end user. Engineers have to care how it works, have to understand. Those who are you are girl here, lady here, make sure you change your mentality from the normal thinking that you do before this. You are an end user to become a leader, to become an engineer, to become a query mind. How this one work? Why, when you buy something, what is the size of this? Who produced this? And so on, so on, so on. Change your mentality from a normal girl to the engineer mind. Can you please?
Sure.
Because normal girl don't have this skill. Your mother don't have this skill. And then bersepah juga yang lelaki tak pandai fikir sekarang ni. 99% of graduate from university now doesn't know how to think. Because they learn by high school method. They don't know how to ask. Make you understand here. They don't know how to ask to explain this satisfactor. They just know how to punch calculator, put number there, 200 there, and then it's 180. So satisfactor is 200, 180. So this one become 1.2. Only the. What's the meaning of 1.2? They cannot answer. Somewhere here, there's another safety there. Why satisfactor more than 2 there? There's all answering there. Asking, okay? Asking. It's not just reading. When you go back, you ask yourself what you read. Not finish at reading. Not finish as you don't understand by you read that explanation. You read the explanation, you go back to number 2. Number 1. Number 1 is you read. Even though you read the explanation, you are still reading the explanation. Number 3 is not reading. Number 3 is digging on what you read. This is never happening yet, you know. You think you have done that. To me, you haven't done that digging because you don't have skill yet. That's why I ask you to use those skills. You read the explanation and then you think you are digging. No, you are still reading number 1. After you read that one, ask yourself, what did I read? What this one is telling you? The term here is telling what? That job is what I call digging. Asking. Are you with me?
Yes.
Please change this if you want to become an engineer. Your character have to be changed. If not, you are not coming to that skill. It's not finished. When I explain this one, you coming home, you finish. You are still in level 1. You hear what my explanation. You see my explanation. And you write my explanation. You are still in level 1. You must recall it back. You must dig it back at number 3. And then apply it back at number 4. See that? I show you an example of that. Chair that one to apply it. Are you with me?
Yes.
So what time is it now?
10:44.
Okay, we have 10 more minutes, okay? So the normal safety factor is 2 to 2.5. This is normal safety factor for engineering material. But for monument, normal engineering material, how many years do we use? Yeah.
10 to
Less than 20 years. Are you with me?
Yes.
Less than 10 years, then 20 years, that's the meaning of normal. Your car, only for 10 years, 15 years. That's the meaning of the safety factor. For material that going to be used for hundreds of years, let's say the Petronas Twin Tower in KL. Is that been designed for 10 years or 20 years?
No.
No, it's been designed for hundreds of years, right? Like the Eiffel Tower in Paris. Like the what's New York, the Empire State Building. Whatever monument that we have in the world here, this is been designed for hundreds of years. 100, 200, 300, 400 years. So for that type of design, the safety factor must be higher. Lot more higher. Let's say for Twin Tower KL. Twin Tower KL, Do you think what is the certain factor for that? Guess.
10.
Okay, I give you assignment. Huh? I give you assignment for this holiday. This holiday, okay? You have a 1 week break. You find 5 monuments on the internet. You find the 5 monuments. You find the detail that one. You find the engineering detail. Whatever it is you have to find. You want to read 5 monuments. One is Twin Tower in KL. The other 4 you can find whatever it is. And what is the certificator do they use? Can you do, please?
Can.
And then, of course, it's higher than 2.5. But how much higher? Because we need 400 more years. Because there are factor of deterioration. The yield from the beginning is 200. From time to time, from 10 higher, 20 years, the yield become less. This is another factor of yield that people don't understand. The new one is 200. Yes, after 50 years, it's not 200 anymore. Macam kita jadi tua lah, kekuatan kita boleh angkat 50 kilo. Umur dah 50 tahun boleh angkat 50 kilo lagi ke? Macam tu lah. That limit tu is become less. Even the material also. And the other factor. What is the other factor? Earthquake factor. So you have to make it stronger. Safety factor there. That's why. Okay, your assignment for this holiday. Name it assignment number what? That assignment is assignment number what, that one? 13, right? Homework 13 is for you to find the certificate of 5 monuments that we have in the world. Find it on the internet. What is the certificate for that monument? When you try to find that one, you cannot find here, find somewhere, until you got a detail there. People write that way. And then there's a job of engineer, seeking knowledge. Okay. So we have 5 theory, that one, certificate. Now you have a little bit understanding why we have a certificate below that one. Okay? Simple calculation for very basic understanding. Okay. Saya ada satu besi nak ditarik. Okay? Saya ada satu besi nak ditarik ataupun nak dimampat ke tak kisahlah. Tarik. Loading. Very simple. X. Loading only. Yeah, the load is 100 kilonewton. Berapa saiz yang boleh saya letak? Berapa diameter yang boleh saya letak? Soalan dia. What is the diameter? For it to be safe. How to do the calculation? How to do calculation? I don't know the size, right? I don't know the size. So P divided by area is equal to stress, sigma X. And then you do the more circle here, sigma X is also sigma 1 there. Your sigma X is also sigma 1, correct? Are you with me?
Yes, correct.
And then you use a Tresca theory. Sigma 1 minus sigma 3 is equal to sigma Y over N. So your sigma Y is 200 still, megapascal. So I want to find the size. I have to set the certificator. So what is the size? So I have to set the certificator of 1 there because I want to find the size. When I got the size there, so what is that then? So P over A there. So this is 0. Sigma 3 is 0 there. Sigma 1 is there. Sigma 3 is there. 3D more circle, the other one is there. And then that one, the other one is also that one. And then you got the sigma 1 is 110 to the power of 3 divided by the diameter. Pi area. Pi d to the power of square over 4. Put up area. P over area is equal to yield 210 to the power of 6. So what is the diameter there? Put calculator.
Square root of D 0.025.
0.025. And then square root it.
Square root D.
Huh?
Square root
Your
D.
D. There's your D. So 0.025 meter. So it's equal to what? It's equal to 25 mm. Is that the answer, 25 mm?
Cannot. Must be bigger than that.
That's what I want to hear. The size must be bigger than 25. The calculation here just to check the limit. The question says, what is the size for that beam? Your answer must be what? You know the calculation for 25. 25 is not the answer. The answer, your diameter must be higher than 25 mm. If you say the diameter is 25 mm, you are not an engineer. You just a high school student punching calculator. Are you with me?
Yes.
There's no such here. Bigger, no here. This is for understanding. After you got a value there, you have to make your akal to make a decision. How do I answer this question? The question is, how do I answer this question? Do I answer it 25 mm? Or else? So the answer should be higher than 25. That means 26, okay, 27, okay, 30, okay. And then when you decide, okay, now, when you understand that one, that must be higher than 35. Now you decide. What is the size of that one with safety factor of 2? Nampak? Ini kepala engineer. Nampak? Mula-mula kita berceritakan size basic dahulu. Without safety factor, apa limit dia tadi tu? Yang kita nampak dah. When kita size of 2, adakah ini jadi 50? No. Yes or no? We have to check. Now you calculate. Safety factor of 2 there, what is the diameter there?
Professor,
Yes.
what if it was thin cylinder? Thin
Say what?
cylinder. If it was a thin cylinder.
Wait, forget about cylinder yet. Forget about cylinder. We are going into that later on. Just this very first example here. I want to make you understand the basic fundamental method.
Okay.
We are going to the cylinder, whatever it is, later we will definitely be going. A simple fundamental method here. What is the size of that, please? Find me your certificate of 2.
0.036.
0.036 to 36 mm. See that? Safety factor of 2, this one become 36 mm. Why not? When 2 here, this one not become 50. Why 36? The answer because square there. Can you see that?
Can.
We can, everything have answer that one. See that? So, where do you want to put? 25, no safety factor. No safety factor means safety factor of 1. This is safety factor of 2. So, where you decide? This is dangerous here. So, this is normal engineering material here. So, this loading is always the important there. So, you decide higher than 36. Because you want the safety factor higher than 2. So, If you buy that, there is 36 or 37 or 38 mm. Gauge here, you can buy that material. Sometimes they don't sell 37, only 36 and 38. Sometimes only 35 and 40. The hardware doesn't sell that size, 37. So 35, 40, you buy 40. Are you with me, guys?
Yes.
This is how things work. Okay? This is how things work. Very simple understanding here. The process is there, calculate there, but that one P over A, that one. You don't know the D there. The P over A, that one, compare to that one, and then you solve it. But it's not just sigma X here. Start with more circle, sigma 1 minus sigma 3. Fresca. This is 0. Sigma 1 is equal to sigma X. And then go back to that. The unknown there. The more circle is unknown there. 100 divided by D square over 4. Are you with me, guys? And these are the basic fundamental. You can do it with various theory. The forward case. You decide your certificate factor, what is the size? Or you already know the size, what is the certificate factor? Are you with me?
Yes.
That's forward case, backward case. Forward case, you know the size, you know the size, you know the loading. You calculate the certificate factor. Is it safe or not? That's forward case. Backward case is what? You decide the certificate factor, you know the loading, you find the size. Or the other one, you know the certificate factor, you know the size, you want to find what is the maximum load that I can put. So all the same question there, just forward case and backward case. 3 fundamental method to do things. Are you with me, guys?
Yes.
Okay, thank you very much. We stop for today. Okay.
Thank you
Tomorrow
so
we'll
much.
continue. Okay. Good luck on your test. Assalamualaikum.
Thank you, Doctor. Waalaikumsalam.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Thank you.
Thank you, doctor.